Welcome back to the second part of our tutorial on Horster. And what we're going to be doing first here is animating a camera path. And if you are making a large-scale urban tutorial or animation and you want to move your camera through space across a site or across Manhattan, this is how you would do that. And we'll show some examples in class. But first, you need a path. And so we've just internalized this curve here. This dash pattern is just a way of turning a line into a dashed line. And eventually you'll see we're using the human tools, the preview custom line weights, just to create the sort of look there. We've created a bit of context as well, and you'll see why in a moment. That'll just be so as the camera is following this dot as it moves along the line, that context will just sort of help you see it as it moves. So the first thing we're going to do is this dot here is going to be the center point of our camera. That's going to be the camera target. And if you reparameterize a curve, then it will have a domain from 0 to 1. And you can use this guy here, evaluate curve, to move along it. So this is exactly what's happening here. If you do not reparameterize it, the domain will be based on the length of the curve, and that's just much harder to predict. So reparameterize the curve, use evaluate curve to create our little point here, and then we're just making a circle, and this is all just for representation, just so we have something to look at. Okay. In the previous tutorial, we used the Horster component getCamera. Here we're going to use the component setCamera. So we need a location and a target. And normally you would not plug the same point into both of these, but as long as you are in top view, that will work just fine. And you're going to need a lens length, which we'll explain in a moment, and you're going to need activate to turn it on. So when we do that, boom, we zoom in. So this is now the center point of our camera, and we can zoom in closer or zoom out further. This looks nice. And as long as Horster is set to true, we can move along that point, along that line. So this this line could just as easily be a street in Manhattan. We could be moving down Broadway. Right now, it really doesn't matter. It's all going to work the same. So that's it for set camera. We left you some little directions in case you get confused, but set camera is really pretty straightforward. So let's look at something a little bit more interesting. In this next example, so one little trick, in general, let's say in Grasshopper you've lost something or it's super small. If you select it and center mouse button this guy here, this little looking glass, boom, lets you zoom. It's like zoom selected for Grasshopper geometry. So here we have created a little cityscape for you that is otherwise not important. But you've probably seen a lot of examples in the lectures in class where there is a building and we are looking out from it from different viewpoints and trying to analyze the view for, let's say, different apartments. So what we've done here is created a little facade, which is this guy. And we are going to subdivide that. And so if you want to subdivide a surface, like so, you can use this guy, which is called isotrim, which is here under the surface utilities. And you need to use, this is always a little confusing or counterintuitive maybe, but you're going to use this divide domain squared, and you're just going to tell it UV is basically like X and Y coordinates in a local geometry space. So local to this surface, we're saying give us 3 in the U direction and 30 in the Y direction. And this is basically, we're just going to call these like apartments in the facade. And you could say, no, I want 4 or 5. It really doesn't matter. You could say I want more or less. This is just a tutorial, so it really doesn't matter. So we have subdivided those guys. And then we are going to evaluate each surface to find the center point for each guy here, as well as the normal vector. And a normal vector is just the vector that's coming straight out from the face of that surface. So first off, when you're evaluating the surface, again, you need to know like a point in UV space to evaluate it. And so there are two things we're doing here. One is just like the curve in the camera path, we are reparameterizing this space so that it goes from 0 to 1. And then this guy here, this is an MD slider. I actually don't know what MD stands for. I'm sure you could Google it. But basically, you just want a domain. This is all it's doing. I mean, we could just write this into a panel, but an MD slider does the job. And that gives you the point and the vector. And we're going to move those points away from that surface by using this amplitude component, which just takes the vector as a directional constraint and then takes another input to define the length. So by default, that normal vector is going to be 1, but we're going to make it 50 instead. So you can see here, we're just moving that point away from the face in that orthogonal direction. And what we're going to do is, again, just like the last example, we're going to set the camera to each one of these. And the goal will be that we can go sort of room by room or apartment by apartment. So here we're at the first one, and we're just going to go tick, 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 tick up, and then shift over to the next row, and then the next row, like that. And what this is going to give us is the view of our little city from each apartment. And so if we take set camera, and again, the location is this point here. The target is the point that we have moved out in space. That target could just as easily, if you were trying to figure out, for example, whether this apartment could see like a park or a statue of George Washington or whatever that was located in this city somewhere, you could set that point as the target. That would be fine too. But for this case, we're just going to get a view going straight out. So if we set this to true, now we are in that ground floor apartment looking out, and as we go up, zoop, we just move up the building. And then this is to the left, sort of the central row of apartments, and then this is all the way on the other side. And so that is a great way, if you were to animate through this slider and take screenshots, you know, you could put like a little vignette, a little person in a room, you know, with a window looking out, and you could just snapshot through that, and you would basically be able to very quickly calculate all of the views from that apartment building. So you can turn that off, and now we can turn around again and see that's the apartment that we were looking out from. Okay, that's it. I hope that's clear. If it's not, you have the script to explore, and we'll be going over this in class as well. So hopefully this covers the full range of things you can do with Horster, from views out of apartments or animated camera paths or orienting geometry for notational purposes. Okay, see you next time.